This is 5.3, identifying proportional relationships, and 5.4, writing and solving proportions. So a proportion is an equation stating that two values of two ratios are equivalent. So an equation including ratios saying they are equivalent. This could be 2/3 is equal to 4/6. We know that these are equal because they will reduce to the same value, and when they are equal, they form a proportion. So we're going to determine whether the ratio forms a proportion. If I have 3 to 7 and 9 to 21, I'm going to rewrite those as fractions and say 7/3 is equal to 9 over 21. I can reduce 9 over 21. Reduce 9 over 21 by dividing each by 3, and I would get 3/7 is equal to 3/7. And we know that these are equal, so yes, they are equivalent. Then we can have 4 to 6 and 18 to 24. Again, I'm going to rewrite them as fractions and reduce each. When I reduce them, I would get 2/3 is equal to 3/4, and no, that is not equal, so they are not equivalent. We can solve proportions, find a missing value, by using cross products. So that means if I do A times D, that is equal to B times C. And then I can solve for a missing value in there. So you're multiplying on the diagonals here. So we are going to tell whether the ratios form a proportion. 6 to 8 and 18 to 24. Rewrite those as fractions, and then we are going to cross multiply to get 6 times 24 equals 8 times 18. And then that gives 144 equals 144, so yes, those are a proportion. Then here I have 2 to 5 and 8 to 15. Rewrite as fractions, cross multiply, and then 30 equals 90. So no, these are not proportions. We can also check a table to see if it makes a proportion. I can take all of these and rewrite the values of the ratios and then write them as fractions. And when I reduce all of them, I would get 1/3 equals 1/3 equals 1/3 equals 1/3. So since they are all 1/3, yes, this does make a proportion. Now we are going to solve for a missing number in a proportion. So if method 1, we are going to solve as if these are the problems in chapter 4, so solving for the missing variable. So if I have 4/5 equals x over 10, to get x by itself, we need to multiply by 10, which undoes this division. So multiply by 10 on the right, multiply by 10 on the left, and 10 times 4 is 40, over 5 reduces to 8, and 8 equals x. Another way we can solve that is using cross products. So if I have x over 9 equals 3/5, I would multiply x times 5 and 9 times 3 to get 5x equals 27. Now we're going to solve for x by undoing this multiplying by 5. So divide each side by 5, and we get x equals 27 over 5. So now we are going to solve and show work. If I have 12 over 5 equals 6 over y, I can cross multiply and then solve for x, solve for y to get 5 over 2 as my answer. So this is process from chapter 4. Undo your multiplying and get your variable by itself. For 40 over z plus 1 equals 15 over 6, I'm going to cross multiply, and then 40 times 6 is 240. Distribute the 15 to get 15z plus 15. Move this 15 without the z to combine like terms, And then 225 equals 15z. Undo the multiplying by 15 by dividing, and 225 over 15 is 15. And here I can have x to 5 and 8 to 2, rewrite those as fractions, undo this dividing by 5 to get x by itself. So 8 times 5 is 40, divided by 2 is 20.